welcome back to another episode of Cloud with Chris. You're with me, Chris Reddington, and here we talk about all things cloud. Now, thank you again for joining. We've got another interesting topic, something a little different again here today, and we're going to be talking about security, a very important topic. And if you think where the industry is going in terms of cloud-based workloads, thinking of our development practices and the agility and the speed at which we're working, sometimes people think that security is this afterthought, but in reality, it can't be. It needs to be something which is integrated into that development lifecycle, and it needs to be something that each and every one of us are thinking about. And that includes my guest today, Mr. Giulio Vian. Hello, Giulio.
Hi, everyone. Happy to be here and have a chat with you.
Excellent. No, glad to have you here, Giulio. And I think very interesting title that you've got here as well, software rotting, and why you need to change your approach to security. Now, very striking title. Before we jump in, though, we should probably start with introductions and who you are.
I'm Giulio Vian. I am a principal engineer in Unum, which is a Fortune 500 insurance company in US. Mm-hmm. I work in Ireland, in Carlow, because we have this big site here with about 200 people, mostly, for everyone in IT, a lot of developers, but also other roles like UX, some IT operation, a lot of specialists.
Gotcha. Awesome.
And my expertise is more, and my work is on the DevOps space at large. So Excellent. A lot of helping the software engineer, helping the teams, improving the process. And security is part of the entire engineering process.
Absolutely, and it absolutely should be. Not everyone thinks that way, of course. I think sometimes it's DevOps and I know security just before we go to production, I think is how a lot of people think of it sometimes. But I guess we've got this trend of DevSecOps that, everyone's now starting to realize, what security really is a part of this cycle. So, interesting talk here. So I guess maybe the best place to start is maybe setting some context, because I guess there's been a lot of things going on in the industry. Like if we think about Log4j, which was last year, I think, or a couple of years ago now, time has merged and blended. Yeah. But, supply chain attacks and all of these different development security vulnerabilities that I guess we're now suddenly seeing more common. It's getting more challenging for developers.
Yeah, absolutely. This is a trend everywhere. I heard the term DevSecOps, which I think is, I'm not the kind of person that split a hair in four for terminology.
Yeah.
Because DevOps is all about people talking to each other. So dev talking with ops, but also with security, with business, with architecture, with everyone in the team. And instead of opening a ticket, the ticket mindset is terrible, and we need to switch. A ticket should be an audit, a trace, a log of what you have done, more than, I need something when you kindly can work on this. That's not a good way. So security is just part of the overall conversation and part of the quality of software, because in the end, what you end up doing is adding some tools from a developer perspective in your daily working on your environment and in your pipelines, in your automation, so that you have additional security checks. And also is about thinking about security when you design your solution, your architecture, but also your classes, how you check your input, which is probably the most common problem, most common generator of security issues in the field.
Yeah. It's absolutely one of those pillars of software quality, isn't it? It's not a non-negotiable. I mean, I guess there was a time maybe where arguably people might say it wasn't as important. I think it's always been important, but I think now the nature of the applications we're building, very high scale, cloud native, on the public internet, typically, they're prime opportunities for people to go and attack them one way or another. And it's all about making sure that we do what we can to reduce that risk, because like anything in the software that we write, it's all about risk management. We could do this, we could do this. What's going to benefit our end users the greatest? And I don't think any end user wants to have their data leaked onto some website paste bin or something like that.
Yeah, and in fact, we work in the insurance space, which is requires a lot of care about personal information. We manage health information, so the company is very focused on, very careful in not leaking anything, having everything protected, under control, and so on.
Yeah,
so
and this is it. This is it. Like, all you need is one single API not secured correctly, the wrong API, and then gone. And this is why it's so important for it not to be an afterthought, for it not to be that kind of checkbox or that ticket, because a ticket can be left and wait until after the fact. Whereas automations, pipelines, etc., having it as part of that process on the way out, that you verify and have a standard set of checks, then you can be sure that there's no regressions. You can be sure of the quality before it progresses.
Yeah, and just to complete the context, the framework of this conversation, security is a multi-layered thing. So you will have some infrastructure security, you will have some web proxy, reverse web proxy that are checking all the traffic going in and out. You will have all the logs audited for security attacks, both from the networking gear, but also from the application to see if there is anything going on. But my conversation is more focused on what developers has to do, care about. So it's more developer focused than in the overall security space.
Gotcha.
Exactly for the thing that you mentioned before, Log4j is was kind of an eye opener for the industry to say, we really need to have security shifting left and deep from the moment we conceive any piece of software.
Yep.
Okay. From the whiteboard.
Yes. Yeah, and like we said earlier, it's just now a pillar of software quality. It's something that has to be there, non-negotiable. And it's like the example of Log4j. It's not necessarily just about the code that you write, but it's also about all the dependencies, all of those things that you're bringing into your application. Because, we don't want to be in the business anymore of writing our own logging system or identity provider or any of these things. We want to go ahead and bring in people who have dedicated their time to just solving those problems, not reinventing the wheel. But of course, with that, again, comes potential attack vectors as well.
Yeah. Maybe we can look at a few of those charts that I was mentioning. Yeah. So, for example, this is the most common graph that you see when someone is speaking about security, which shows you the increase in the number of vulnerabilities discovered year over year. And we see that clearly the trend is not slowing down, it is going up.
Indeed.
Could be that people is writing more software than in the past, so the ratio of security issues is the same as in the past, but we are just writing more software. Or that we have more analysis on the software we write, more caring about security. I don't know. But the ratio is increasing. So it's more and more common to find issues in software. And we are talking about the developers and what they use. So I think we need to think about how dangerous they could be. So this is coming from the Google Project Zero.
Yep.
which is kind of famous. It's an initiative from Google of trying to make the web secure. One reflection of this is the frequency of updates in the Chromium core of browsers that is used by both Chrome and Edge and a few others. The number of exploits is increasing. So it's not just that we find software vulnerable, but those vulnerabilities are exploited by attackers.
Yes.
And we are seeing more and more common theme in the news, more news that says, oh, this organization was compromised thanks to something. Okay. And people specialized in security, so my colleagues, they see these type of attacks. They see in the logs and so on. So they are trying to defend by protecting the perimeter first of all. But we as developer have changed the way we write software. Because I remember in the 90s, when you wrote a piece of software, it was, for example, a C++ application, and you use a couple of libraries. Okay, you use the standard libraries and maybe Microsoft MFC to draw the UI and all those things. Or maybe you were writing a Visual Basic application and you have a couple of components, maybe to do graphing or reporting, stuff like that. Nowadays, we use tons of applications. There are a lot of stats. I think here is from Sonatype, so the people that are behind the SonarQube that made some stats. The usage of libraries is going up year over year, so we have more than 50% increase, up to doubling the number of usage in pipelines. Of libraries. Yes, this data could be misinterpreted because we have people not just building on their machine, but also pipelines, they download again. But in general, the trend is kind of clear. Modern software is written using libraries, third-party libraries, and open source libraries. Another interesting thing is about the different languages, the different application stacks. They have a different usage of third-party libraries and open source libraries. So, for example, the typical .NET application use a lot less libraries than others, and thus the number of vulnerabilities that you find is proportionally lower to something like JavaScript, where the average JavaScript application is using hundreds of different libraries. Typically not in a direct way, but in an indirect way. So the typical .NET application has something around 15 libraries, while the typical JavaScript application is using 200 libraries.
Wow.
Yeah, it's a Russian doll effect. So you pull in a framework, and this framework is composed of 100 libraries.
Yes, those transitive dependencies. Yeah.
Yes, those transitive dependencies. The different languages have a different depth and reuse of software. So that's an interesting thing, and this reflects on the number of vulnerabilities that you find and discover. People are using more open source, so we need to consider how good is open source in catching up with security issues. And here I have another couple of interesting graphs that clearly shows you how quickly the open source maintainers are patching the libraries, the frameworks that you are using. Data from Snyk is kind of scary because you can have a couple of months before some vulnerabilities get fixed. Because maybe it's a a maintainer working on weekends. Okay. And the library is a deep nested dependency that people uses, so they don't even realize that are using that library. While a small percentage, typically the most commonly used libraries and frameworks that are supported by big groups. I can think of React in the JavaScript world, or .NET framework, stuff like that, get quickly updated compared to others. So that's something else to consider. Sometimes we have to patch things ourselves because we cannot wait the maintainers, and we need to be ready in updating our software because zero-day exploits are becoming more and more common. So there is a responsibility on developers in patching the software. One final note is that we, in addition to libraries, so we are taking an explicit dependency on a library, say a login library like log4j. We have other implicit dependencies. Our application stack is updated very often nowadays. If I go back in time, I think of how often you get a new version of System 5 Unix or a new version of Windows. It took years before you get a new one. Nowadays, a new version of .NET, Java, Node.js is coming out every 3 years and even less. But that's one thing. That's a major version. We need to consider the patches of the platform because those get patched a lot more often. For example, you have a new version of Chrome twice a month. That's kind of the peak. But Node.js, you get a new patched version with security vulnerabilities patched every month. How does it care? Who does care about it? It cares two kind of persons. The IT operation, when you have that your application platform is deployed independently from the app, which is the case you are using virtual machines, for examples, and they need to reissue a new patch of the virtual machine, maybe a new image or something like that. But if we are using Docker, the application stack is within the Docker image. So it's up to the development team typically to regenerate a new image every month, so you make sure that you get the latest patches. Otherwise, you are pushing this Docker image into production with vulnerabilities. So there are at least these two pieces that developers should really care in their software development lifecycle: libraries and application stack.
And just to jump in on that one there, Giulio, as well, there's also something that you kind of implied in there that is really important. So specifically talking about the points around like Docker and the developers, effectively the development team, having to go and regenerate that image. The thing is, though, and same argument for the virtual machine going up a version level, for example, you still have to make sure and do the checks that the application is going to work in that environment. You just can't assume that actually, everything's going to work fine. There's been no framework changes or library changes behind the scenes. And this is why it's so critical, back to our conversation earlier, having that shift left mentality, having already started things like your continuous integration, having those unit tests and those effectively being as rigorous as you can at the relevant points, checking the quality, because then once that patch comes along, all those tests run and you can go, oh, look, it all compiled, it all built fine, our unit test passed. Let's go. And we're up to date. And that's how you maintain that agility and maintain that speed. It doesn't have to be security versus that speed. It can be both, but it takes that investment.
Yeah, I would even say the security requires automation.
Yes, agree.
Security requires that you have a good, well developed deployment process that goes from code to production, which include a lot of quality checks.
Yes.
Just because you need to release anyway, even if you don't release anything new on your application, you need to release a new patch of this application stack, maybe refresh the libraries, even not touching the code, even a mature application that doesn't require new feature, you need to redeploy again and again. And you cannot do this from your laptop. You
And
need to
it's,
have a proper CI/CD process up and running
yeah.
with all the automated tests, so you make sure that the patch is not breaking anything.
Do you know what? That would be a really fun and interesting poll. Effectively, if you had an audience with you, or maybe on Twitter or something like that, how many of you actually do a build of your application when there's nothing new to deploy? Or sorry, a build and a deploy if there's nothing new feature-wise, but actually you discover, oh, it's upgraded to the latest version. We need to go and do that. It would be very interesting to see those results, because I'm not sure how many people actually do that.
No, I think I cannot say a new idea, but it's something really uncommon.
Yes. Yeah. Interesting. But the thing is, as well, the kind of the tooling that's out there as well. I know I'd be biased given the company I work for, but the tooling out there is getting better and better as well to go and solve these challenges as well. It's not like you need to reinvent the wheel. There's plenty of platforms out there that can help you keep on top of these dependencies, be able to understand those code flows, etc. Wow! You didn't even have to pay me for that transition. There we go. Back over to you, Giulio.
No. It's all good. It's okay. We discussed that we have vulnerabilities. Okay, when I know that I need to upgrade a library, okay, what can help you is the kind of tools named software composition analysis.
Yes.
There are a lot of examples out there. There are even some open source tools that can help you in that for some application stacks. The software composition analysis is a tool that will look at the dependencies of your application, typically looking inside your package JSON, inside your CS project, inside your project file, your POM XML, whatever your application stack is using, and look if you are using a version of the library that has a known vulnerability directly or indirectly. So maybe a dependency of a dependency has the vulnerability and will warn you. And some tools even goes to the level of proposing a patch, proposing the right version to use. So
yes,
depending how much money you want to spend. But I highly recommend them. For example, we are using X-Ray because it's well integrated with Artifactory, which is our tool we use for artifacts. But that's our history. Yes. Maybe you have nothing and you can pick and choose the best in the market. Keep in mind that for Node.js, there is NPM audit that will tell you if you're using a library with a known vulnerability. And there is also this dependency check from OWASP that does some work. Up to you if you prefer a commercial product or an open source one is enough. Typically, you embed this product in two phases. The developer should run them before committing code, so they make sure that they're using the proper version of the libraries. But you still have to have them in your pipeline, in your CI/CD, so that by just rerunning, you get alerted if there is something wrong. Some tools are so good that they will scan your source code repositories, Git. So, for example, GitHub Dependabot will scan your source code even without, so you don't need to build anything. You get alerted that there is something to upgrade.
You did my job for me. I was going to talk about Dependabot there. So there we go. No, Dependabot is great. Setting a poll up for however long you want to do. And even in some cases, running the alert and generating the pull requests for you as well. And that comes back to what I said earlier about having all of those checks and pipelines in place so that as soon as that external tooling does that for you, it makes it really easy to just go, you know what? I can adopt that because I know my builds have passed. I know that unit tests and everything else has passed. So I'm comfortable that actually that dependency doesn't break at least what I'm testing for right now. And if it does break something, then that shows actually you need to write some more tests probably. So, it's that kind of DevOps mindset there.
Correct. And there is another tool that we have to mention, which is static application security testing. But you always see the acronym SAST. We talk about third-party code in libraries, in runtime, in operating system, but you need to make sure that you're not creating security issues in your application. Clearly, you need to think in terms of attack when you design the code, when you write the code, but a tool like a SaaS tool, it's very helpful in identifying code with potential issues. So you have, for example, SonarLint or SonarCube or SonarCloud, the family of Sonar thing that is doing a decent job. We're good also if you don't have a lot of money to spend. And there are more sophisticated tools from the vendor that I mentioned here: Black Duck, White Source, Bolt, Sync. They do a great job in scanning your source code. Veracode is a very famous one. And identify issues in your source code, and this code that you maintain.
I should add one more into the mix as well, which is CodeQL, part of GitHub Advanced Security as well. I wouldn't be doing my job, I guess, if I didn't call that out. But yes, many options out there, many different tools. And I think the key thing that we're seeing is you at least should be thinking about these if you're not already doing this. If you're not doing this, start investigating, because that is the best way to make sure you're adopting some of those best practices, common approaches like OWASP Top 10, for example, being able to even understand in some of these different tooling, writing your own custom rules to check if you're doing certain patterns in your code as well. That combined with the dependency piece drastically increases your security posture. You can never say you're fully secure, because something might come out tomorrow and change everything, right? But at least you're doing what you can to make sure that you're on your way.
Yeah, you've done what you could. And so from a professional perspective, you've done the best you could. So a very professional job. Yep.
Excellent.
I agree.
Good. Covered lots of concepts there.
Yeah, I'm skip a few ones. No, I don't have any more slides. So
sure.
That's all.
Oh, good. So really good discussion there, and I think it highlights the need for these security tools being built and integrated directly into our development lifecycle. At the end of the day, we are all part of the security team. It's not just the security team who maybe have that more traditional mindset in some places. It's about thinking differently, adopting to those new ways of working, using the tooling to help us and bring security as part of that workflow.
Yeah. If you want to mention another a strictly related topic, we have taken a the single developer perspective until now. If you think this set of tools, the problem of vulnerabilities in a more enterprise context, because I'm managing about some hundreds of developers, the scale will make you think of needing additional tools on top of these basic tools.
Yep.
Because, for example, SCA is great, but you need, for example, to do a completely different job, which is security. We have a new vulnerability. We need to identify all the impacted applications. So
Inventory.
it's no more the team that is taking care of making sure that my own application is good, but it's the enterprise. We have a new thing like Log4j, and we need to review all the Java application if they are using Log4j anywhere.
Yep.
And this requires a bit of organization, knowing which pipelines are used to redeploy stuff, having an enterprise-wide bill of materials of all applications, so we spot identify all the impacted applications, we know what to rebuild, we know what to redeploy, and so on and so forth. So managing this thing at an enterprise scale need additional tooling and design and more complex processes. Sorry.
No, you're good. So as an example, I'll share my screen actually,
Great.
and just show one of my GitHub repositories here. Actually, let me just do this. Try this again. Okay. There we go. And I think you should be able to see. This is actually my Cloud with Chris organization, and I only have 16 repositories, right? This is the important thing to mention here. But within that, we can see that I've got 886 of these dependencies. This is something which came out, I think, over the last week for all GitHub Enterprise or Teams. I can't remember the SKU exactly, but I can go and look at the various licenses or ecosystems, go and take a look what's in there. And having this data, as you say, and this information, so I can quickly then go, okay, what repositories actually have checkout v3? Let me go and take a look, for example. Oops, I've clicked straight into the action there instead. But being able to understand and take a look at those dependencies then is, as you say, I think in those critical situations where actually, something is going wrong, we need to identify it and catalog that.
Yep.
Important. Very important.
Yep.
Good. So I guess then, working towards wrapping us up here, if you were maybe someone who's listening in and thinking, okay, this sounds interesting, this sounds important, sounds like something I should be thinking of, what would maybe be the kind of top 3 things that you would tell them to go and do as the next step?
Well, get acquainted with this security tooling, SCA and SAST as the primary one, the starting point. There are additional tools, dynamic testing, there are a lot of other stuff, but software composition analysis, software analysis are the basic ones.
Yes.
And they are easy to implement because SAS tool could be a bunch of rule in Visual Studio or in a .NET project. Could be running npm audit for SAS. So it could be very, very simple to adopt and integrate and even ship. Some are even open source. That's the starting point. And from there, you need to study and learn what else is around there, other tools, but also the basic concept. OWASP has a lot of good training material, and I highly recommend this. More than the tooling, the process the ideas, the concept that they explain and translate. Mm-hmm. Because in the end, the top 10 vulnerabilities are always bad checking of input data, SQL injection, and so on and so forth. Yeah, so that's the thing.
Good. And I think maybe another one I'd just layer in with something we talked about is making sure you've got that automation in place, because having that in place, those builds, those unit tests, etc., to check the quality, then helps you just bring it as part of that cycle, helps you just make it something natural as part of your process, and doesn't compromise any speed then as well. So there we go. Absolutely. Excellent session there, Giulio. Thank you so much.
I thank you. It was a nice chatting.
Yes. No, and I'm sure we could have talked for much longer as well and dive deeper into some of those. So I'm sure no doubt we'll have to have you back to talk about more very soon.
I restrain myself from talking too much.
You're very welcome. Giulio, thank you so much, and speak soon.
Thanks, Chris. It was a pleasure.
There we go, folks. So we have been learning here all about software rotting and this idea that over time, if we don't maintain our software, as we've been talking in terms of dependencies, in terms of the actual code we're writing, through the use of things like software composition analysis tools, static application security testing tools as well, then we're potentially going to get left behind and could leave ourselves vulnerable there. So go ahead, start automating those builds, those unit tests, etc., as part of the cycle, so you can easily go and bring security into that life cycle as well. So with that is today's session. So thank you so much once again for joining. And you know what to do. If you've liked the session, please go ahead, hit like, subscribe, share with others. And of course, if you want to see more similar content to this, let me know and we can make sure to make that happen. So with that, thanks for tuning in and see you on the next one. Bye for now.